AI fans, welcome back to AI Breakdown. Our focus today is on a really interesting paper, OneLLM, one framework to align all modalities with language.
Hey Megan, absolutely. This model is super impressive. It pulls together 8 different types of data all into this language-centric framework. It's set to really change the way AI systems can understand different inputs like text, pictures, sound, and more.
And on the very first page of the paper, which you all can see on your screens, we get our first glimpse into how OneLLM is aiming to improve AI's ability to handle diverse sets of data.
So OneLLM is doing something different from previous AI systems, isn't it?
Right, other systems often had separate parts for each kind of data. But OneLLM uses a single encoder that works across multiple data types, kind of like a universal tool.
It's interesting because the paper outlines several significant advances. Like they came up with this single framework to work with various modalities and put together one LLM for 8 separate modalities. They've also created this substantial multimodal dataset.
Yes, and that's key for enabling OneLLM to handle different tasks, like making captions, answering questions, or even complex reasoning from various types of information. Let's check out Figure 1, which is where the innovation really starts to shine.
This figure gives us a visual on how one LLM is diverging from the usual route. Instead of having a single focus on images or separate pathways for each data type, one LLM has this unique component.
That's right, it uses something known as modality tokens to help it switch between different data seamlessly, which is a pretty comprehensive approach.
Getting into the details with Figure 2, tell us what's going on here, Megan.
Sure. There are these modality-specific tokenizers that kind of translate each input, whether an image or sound, into a language the model can work with.
And then it's the universal encoder's turn to shine. It takes these tokens, working with a projection module, and channels them into the language model for processing.
It's this organized and efficient design that's crucial for OneLLM, especially because it's dealing with such variety in data types. Performance is where we really see if OneLLM measures up, and if we look at page 6, it shows us exactly how it stacks up against other models.
Yep, it doesn't just keep pace. In many tasks, it actually does better. We're talking about tasks that blend images with text, or those that involve more complex data like audio and video together with text.
And it does well by various metrics, scoring high in both accuracy and CIDR, which is a measure of the quality of the text it generates. It's setting high standards for sure.
But can OneLLM handle real-world data? Figure 3 gives us a good idea, doesn't it?
It really shows that OneLLM isn't just a good theory. It shows promise in actual use cases, adeptly dealing with real-world inputs across images, audio, and more. AI systems need tweaking to get to their best, which is where ablation studies come in. And that's what Table 8 is about.
They tested the universal encoder in different ways, like using a static CLIP-ViT as opposed to a more adaptable version.
And it's through these tests that we get insights into OneLLM's ability to flexibly understand and process a range of data types.
As we wrap up, we turn back to the cover of this remarkable paper, which is really a testament to the strides OneLLM has made.
It's an impressive advancement connecting 8 diverse data types through language, and it's showing strong performance across multiple tasks. OneLLM is shaping up to be a major player in the field.
That's all for this episode of AI Breakdown. We're glad you joined us for another exploration of AI's leading edge. We'll see you next time for more AI insights.